Okay. Punta tayo sa second topic natin for today's lecture, which is torsion. Okay. So when we say torsion, it is somewhat related to twisting. Ano? So a bar is said to be in torsion when a bar is rigidly supported in one end and twisted at the other end by a twisting moment T. That is equal to yung F, yung couple na F, times yung distance ng dalawang forces with respect to each other. Okay? So this bar is rigidly supported at this end. Tapos pagka in-applyan natin ng couple or twisting moment sa end niya, magkakaroon tayo ng deformation. So this bar is said to be under torsional stress, torsional shearing stresses due to that torque or twisting moment. Okay? So yung theta, yung torque, yung L, we will be discussing that in detail sa mga susunod na slides. So before we dive further sa topic natin na torsion, let us talk about axis symmetrical section and non-axis symmetrical section. So first, dito sa axis symmetrical sections, these are sections kung saan yung cross-section natin ay consistent siya when that cross-section is rotated about its centroidal axis. Okay? So for example, itong uh, uh, circular section natin, pag ni-rotate natin yan, it will remain a circle. Okay? Hindi magbabago yung dimensions niya and so on and so forth. And mostly yung yung moment of inertia niya. As compared to this non-axis symmetrical section, kung saan cross-section natin ay rectangular, pagka ni-rotate natin siya or pag nagkaroon ng twisting sa ating cross-section, nagkakaroon ng change sa shape niya. So pagka nagkakaroon ng rotation kasi sa cross sections natin, nag-iiba yung pag nagkakaroon ng rotation sa cross sections na rectangular, nagkakaroon ng changes sa moment of inertia niya. And yung moment of inertia kasi it is yung resistance to bending, resistance to twisting, and so on and so forth. So kung nag-iiba yung resistance ng ating cross section, mahirap i-predict yung mga yung behavior ng ating material. Kaya mostly sa design ng mga machines, sa mga shaft sa mga machine, 'di ba? Ang ginagamit natin ay circular sections because it is very convenient at madaling i-interpret yung mga yung mga properties niya. Okay? So that's why sa mga problems natin at sa mga exams natin, we will be focusing solely on axis symmetrical sections because mahirap nang i-predict yung mga values, mga moment of inertia ng non-axis symmetrical sections. Okay? So, ayan. So, axis symmetrical section and non-axis symmetrical section. So, let us go sa torsional shearing stress. So, to understand yung torsional shearing stress, so let us take this bar. So, meron tayong radius, tsaka meron tayong length. Okay? It is circular, tapos it is subjected to a torque T. Now, to understand yung torsional shearing stress, let us imagine itong bar na ito to be composed of an infinite number of disks. Okay? So, for example, itong disk na ito, pagka nagkaroon tayo ng twisting or in-applyan natin ng torque, tapos nag-deform yung bar natin, yung mga disks na yan, nagkikiskisan yan sa past each other. Kung maalala natin sa shearing stress discussion natin na when two sections tend to slide past each other, a shearing stress is developed. Okay? So, ganun yung nangyayari pagka pag a bar is subjected to a torque T. Now, for a solid or hollow circular shaft subject to a twisting moment T, the torsional shearing stress tau at the distance rho from the center of the shaft is rho is equal to T rho over J, which is yung polar moment of inertia. Okay? So, itong equation na ito, it is applicable when we are considering a point sa ating cross-section. So, for example, itong cross-section na ito, if we are considering this point distance rho from the center. So ito yung equation natin for shearing stress. Okay? And if you observe yung rho natin, pag palaki ng palaki, ibig sabihin yung stress natin palaki ng palaki. Okay? And pag yung point of interest natin ay nasa pinakamalayo na point from the center, makukuha na natin yung shear max. And yung pinakamalayong point from the center is just yung radius ng ating uh, cross section dito. Okay? So therefore, yung rho max natin, that is just equal to yung torque times yung radius ng ating shaft all over yung J, which is yung polar moment of inertia. Okay? So that is yung introduction for torsional shearing stress. Okay? So let us look at this variable J. So J is called the polar moment of inertia. So, let us discuss about that for a moment. So, pag sinabi nating polar moment of inertia, um, it describes a cross-section's resistance to torsion due to its shape. So, in other words, pag sinabi nating polar moment of inertia, it is the cross-section's ability to resist twisting. Okay? Twisting. Okay? Pag sinabi naman nating pag sinabi nating moment of inertia naman, it is the cross-section's ability to resist rotation or bending. Okay? So, yun yung yung concept ng moment of inertia. So, equation natin for polar moment of inertia ng solid cylindrical shaft, that is just equal to pi d 4 over 32. Okay? Tapos pag ilalagay natin siya dun sa equation natin for rho max, makukuha natin yung equation na 16t over pi d cube. At ganoon naman dito sa hollow cylindrical shaft naman, kukunin natin yung polar moment of inertia ng mas malaking diameter, tapos ibabawas natin yung moment of inertia na mas maliit na diameter. Okay? At pag isasalpak natin yan dun sa equation natin for maximum shear, makuha natin yung equation na 16t d all over pi d fourth minus d liit raised to 4. Okay, so yan yung mga equations natin for polar moment of inertia. Okay, so hindi nyo naman na kailangan i-memorize to as long as alam niyo yung equation natin for shear max. Alam niyo yung equation niyo for polar moment of inertia. But madali lang naman na-derive to so check na lang kung paano na-derive itong equations na ito later sa inyong mga notes. Okay? So, polar moment of inertia, so it is the ability of a cross-section to resist twisting. Okay? So, kaya kung makapansin natin dito sa ating equation, si polar moment of inertia, it is inversely proportional sa shearing stress. Okay? So, in other words, pag yung polar moment of inertia natin ay malaki, yung resistance natin to twisting ay malaki, yung shear stress natin ay nalilimit or napapaliit natin. Okay? Kapag yung polar moment of inertia naman natin ay maliit, okay, kung maliit lang yung resistance natin to twisting, yung shearing stress natin ay na-maximize natin or lumalaki ng lumalaki. Okay? So, that is yung torsional shearing stress. So, another thing na kailangan nating ma-determine, hinahanap sa mga problems ay yung angle of twist. So, the angle of twist is yung deformation, yung angular deformation ng ating rod that is in theta. Okay? So, the angle theta through which the bar length L will twist is theta is equal to torque times length over jg, where T is yung torque, L is yung length, J is yung polar moment of inertia, at yung G natin ay yung shear modulus natin or yung modulus of rigidity natin. Okay? And yung units ng ng theta na ito ay in radians. Okay, in radians. And kung mapapansin nyo again, yung polar moment of inertia natin ay nasa baba na naman. Because kung mas malaki yung polar moment of inertia natin, mas maliit yung magiging deformation natin for this bar. And in the vice versa, pag maliit naman yung polar moment of inertia natin, yung twisting natin ay mas malaki. Okay? So, that's yung angle of twist. And lastly, alam naman natin na yung mga shaft natin, it is used to transmit power. So, sa mga makina natin, di ba, yung mga shaft na yan, they are subject to, umiikot yan. So, pag umiikot yan, pag marami na siyang, pagka ginagamit na siya sa makina, may power siyang na-generate. Okay? So, a shaft rotating with a constant angular velocity omega is being acted by a twisting moment T. The power transmitted by the shaft is, yung power is equal to yung torque times yung angular velocity W. Okay? Pag naka-radians per second yung unit natin, ito na yung gagamitin nating equation. Tapos, pagka yung angular velocity natin ay naka-revolutions per second, ito yung gagamitin nating equation. 2 pi t times yung frequency ng natin or yung number of revolutions per second. Okay? So, again, yung natin and yung unit ng power natin ay in watts. So, later on, makikita natin yung basic units ng watts. Okay? So, with that said, pwede na tayo mag-proceed sa ating first sample problem. So, sample problem 304, we have a steel shaft that is 3 feet long and has a diameter of 4 inches, and it is subjected to a torque of 15 feet. So, determine the maximum shearing stress and the angle of twist using shear modulus of 12 times 10 raised to 6 psi. So, solving for the maximum shearing stress. So, ang kailangan natin ay TR over J. So, meron tayong torque, meron tayong radius, or diameter, tapos meron tayong J. Makukuha natin yung J, masasolve natin yung maximum shearing stress. Okay? So, maximum shearing stress. So, solve muna natin yung polar moment of inertia ng ating cross-section. So, we have diameter na 4. So, this is a steel shaft. So, hindi naman in-indicate na hollow steel shaft. So, let us assume na solid siya. So, we have pi over 32 times d raised to 4. Okay. So, diameter natin na 4 inches. Substitute lang natin. Makukuha natin yung polar moment of inertia na 8 pi inches raised to the 4th power. So, now we have yung polar moment of inertia. Ilalagay na lang natin siya dito sa ating equation. So, we have maximum shear is equal to 15 kips feet. Okay? So, tingnan natin yung units natin. Yung modulus of rigidity natin ay pounds per square inch. So, dapat yung 15 kips ay magiging pounds. Tapos yung feet dapat magiging inches. Okay? By the way, hindi pa naman natin gagamitin yung modulus of rigidity. So, okay lang na kips muna yung gamitin natin. So, ang i-convert ko lang dito muna ay yung feet. Ginawa ko muna ng inches yung feet para may consistency ng units. Tapos, yung magiging stress natin would be kips per square inch. Pag ginawa yung pounds ito, magiging pounds per square inch yung yung shear stress natin. Okay? So, yan, 15 kips feet times 12 para maging inches yung feet dito times yung radius natin na kung yung diameter natin ay 4 inches, ito ay 2 inches na lang. Okay? And then we have all over yung polar moment of inertia, 8 pi inches raised to the 4th power. Then, calculating, we will get the value, the maximum shear of 14.3239 kips per square inch. Okay? Pag tinimes nyo ng 1,000 to para maging pounds, magiging 14,323 0.9 pounds per square inch. So, gano'n lang yung mga may minor differences pagka pinalitan natin ng pounds itong 15 kips. Okay. So, nakakompute natin yung maximum shearing stress. Ang hinahanap pa sa atin ay yung angle of twist. So, what is the angle of twist for this particular problem? So, para mahanap natin yung angle of twist, so we have theta is equal to TL over JG. So, meron tayong given na torque, meron tayong given na length, polar moment of inertia, tsaka shear modulus. So, makukuha na natin yan agad. So, we have 15 kips feet. So, dito na papasok yung consistency of units. Dapat i-check nyo lagi. So, PSI tayo, yung modulus of rigidity natin. So, dapat lahat ng other units natin ay naka-pounds or at inches. Or pwede naman, dahil na keeps feet, dapat itong PSI naka-KSI or keeps per square feet. Okay? But, kayong bahala, basta tama yung units nyo. So, ang gagawin ko, i-convert ko muna into pounds tsaka inches lahat ng units natin. So, I have 15 kips. Multiply ko ng 1,000 para maging pounds. Tapos yung feet dito, multiply ko ng 12 para maging inches. Tapos yung length natin na 3 feet, multiply ko ulit ng 12 para maging inches. All over 8 pi inches to the 4th power times 12 times 10 raised to the 6 psi. So, okay na yung ano natin, units natin dyan. Pwede na natin isolve sa calculators natin. Okay? So, pag pinindot natin to sa calculators natin, makukuha natin yung sagot na 0.0215 radians. Okay? So, this will be your answer pag yung hinahanap sa atin na angle of twist ay radians. But in this case, hindi radians yung pero yung standard na hinahanap na angle of twist, hindi siya naka-radians, but naka-degrees. So, itong radians na ito, dapat i-convert pa natin siya into degrees. So, we have i-multiply lang natin siya ng conversion factor na 180 over pi. Okay? So, nakuha to from the circle, di ba? So, isang rotation ay 2 pi. So, that is 360 degrees. Okay? And so on and so forth. Okay? So, ito yung may conversion factor natin. Oh, and by the way, bago kayo, dapat i-store nyo muna yung value na nakuha nyo dito. I-store nyo sa A. Tapos saka yan yung gagamitin nyo dito sa equation na ito para maging ma-limit yung error natin dito sa ating final answer. Okay? So, pagka yung whole value yung gagamitin natin na theta dito, ang makukuha natin na sagot ay 1.2310 something. Kung di ako nagkakamali. So, may slight difference pero in the long run, pagka nag-round na kayo agad dito ay baka magkaroon kayo ng malaking error. Okay? So, ayan. So, this will be yung solution natin for problem 304. So, the angle of twist is 1.2319 degrees. Okay? Next problem tayo. So, for our next problem, so problem 305, what is the minimum diameter of a solid steel shaft that will not twist through more than 3 degrees in a 6-meter length when subjected to a torque of 12 kN/meter? So, ang hinahanap sa atin ay diameter. Meron tayong given na angle of twist, meron tayong given na length, meron tayong given na 12 kN/meter, tapos meron tayong hinanap sa atin na additional, what is the maximum shearing stress developed. Okay? So, meron din tayong given na modulus of rigidity. So, proceeding. So, ito yung mga given natin. So, we can directly solve for diameter. So, to find the diameter, kukunin natin si theta. Okay? So, again, yung value natin for theta or yung angle of twist, that is equal to TL over JG. Wala namang diameter dito. Okay? Meron tayong given na theta, meron tayong given na torque, meron tayong given na length, meron tayong given na G, wala tayong given na J. Pero ang hinahanap natin ay yung diameter, di ba? So, yung diameter, meron tayong diameter dito sa J na ito. So, i-isolate muna natin si J sa isang side. So, we have J is equal to TL over theta G. Tapos, alam natin na yung polar moment of inertia for a solid steel shaft ay pi over 32 d raised to 4. So, ilalagay lang natin siya yung value na yan dito sa ating equation. So, we have pi over 32 d raised to 4 is equal to Tm over theta G. Okay? And then, getting a formula for diameter, we will get the equation 4th root of 32 TL over theta over pi theta G. Okay? And then, it's just a matter of substituting yung mga values na given. So, given yung T, given yung L, given yung theta, given yung g, makuha natin yung answer natin for diameter. So we have 32 times yung torque na 12 kilonewton meter. Nakasanayan natin, newtons tsaka millimeter ang unit natin. So multiply ko ng 1,000 para maging kilonewton, para maging newton. Tapos multiply ko ulit ng 1,000 para maging millimeters. That is yung torque natin. And then yung length naman natin na 6 meters. Gagawin natin siyang millimeters, kaya multiply ko ng 1,000. Okay lang. Tapos all over pi. Tapos yung theta natin na 3 degrees. And yung kanina, di ba yung sinabi natin, yung angle of twist na to ay naka-radians. So dapat yung degrees na yan, papalitan natin ng radians. Kaya i-multiply natin siya ng conversion factor na pi over 180 degrees para makancel yung degrees. Okay lang. So we have theta na yan. Tapos yung g, which is yung 83 gigapascal. Tapos nakasanayan natin, megapascal yung units natin. Kaya multiply natin ng 1,000 para maging megapascals. So calculating sa calculators natin, we will get the value for the diameter na 113.9761 millimeters. And again, make it your habit na i-store yung values na yan sa calculators nyo kasi baka kakailangan ninyo siya later sa mga problems na sinusolve. Okay? So the diameter natin ay 113.9761 millimeters. Alright, proceed tayo sa sa second part ng problem na ito. So nahanap na natin si diameter natin. Hanapin na natin si shearing stress. What is the maximum shearing stress develops sa shaft na ito. Okay? So finding the shearing stress given yung torque, given yung diameter and everything. So we have shear max is equal to 16T over pi d cube. Okay? So given yung torque, meron tayong diameter, we can solve for the maximum shear directly. So we have 16 tapos yung torque na 12 kilonewton meter. Again, convert natin into newton, convert natin into millimeters. Kaya multiply ko ng dalawang 1,000 all over pi tapos yung diameter na 113.9761 millimeter cube. Okay? So ito yung naka-store dapat sa ano. So makikita mo dito na very handy yung pag-i-store ng values sa calculators kasi imbes 1, 2, 3, 4, 5, 6, 7 7 characters ang ilalagay mo dito, A na lang yung ilalagay mo dito. So you can solve for the maximum shear faster. Okay? So we have the maximum shear na 41.2772 megapascal. So ito na yung maximum shearing stress for the problem number 305. Any questions so far from the class? Any reaction? Okay. So, yan. So let us proceed sa ating next problem for this topic. So, problem 307. So, problem 307, a solid steel shaft 5 meters long is stressed at 80 megapascal. So, when twisted through 40 degrees, so using G is equal to 83 gigapascals, compute the shaft diameter. So, what power can be transmitted by the shaft at 20 hertz? So, let us look muna sa given natin. Meron tayong given na length, 5 meters. Meron tayong 80 megapascal na stress. That is shearing stress. Okay? So, meron din tayong angle of twist na given na 4 degrees. Modulus of rigidity na 83 gigapascal. And we are asked to find what is the diameter. So, diameter na naman hinahanap sa atin. So, let us solve for the diameter. So, gaya ng kanina, kunin natin yung equation for angle of twist. Okay? And then TL over JG. So yung J natin, yung polar moment of inertia, makukuha natin yung diameter dyan. So we have TL over, J is equal to TL over theta G. Ngayon, uh, sige, ano muna natin. So, polar moment of inertia for solid steel shaft. So, it is a solid steel shaft. So, yung polar moment of inertia natin, that is equal to pi over 32 d raised to 4. Okay? So, yan yung i-substitute natin, gaya ng ginawa natin kanina. Ngayon, ang problema dito, wala tayong diameter, tapos wala tayong torque. Wala tayong given na torque sa ating problem. So, let us take this as an equation number 1 natin. Okay? At dahil hinahanap sa atin ay diameter, so we should take t in terms of the diameter. So, simplifying, isolating t sa isang side, we get the formula for torque na pi theta g d raised to the 4th all over 32L. So, this will now be our equation number 1 para ma-solve si diameter. Okay lang? So, we have equation number 1. Let us consider other routes para mahanap natin si diameter. Okay? So, ito na yung na-solve natin. So, let us solve for maximum shear na. Okay? So, for the maximum shear sa ating kasi nga, di ba, may given tayong shear na 80 megapascal. So, magagamit natin yung equation natin for maximum shear. So, we have maximum shear that is equal to 16T over pi d cube. Ito yung equation natin na nakuha ka. Yung pinresent ko sa inyo kanina. Okay? So, 16T over pi d cube. At ito yung equation for solid steel shafts pala. So, we have 16T pi d cube. Meron tayong equation for T na pi theta g d raised to 4 over 32L. So, T in terms of D. So, ma-eliminate natin yung isang unknown dito. So, we have shear max is equal to 16 pi theta g d raised to the 4th all over pi d cube 32L. So, basic algebra na lang to. So, cancel yung mga like terms. So, d to the 4th, may iwan sa ating numerator ay si d. Tapos, magka-cancel si pi. Tapos, 16 over 32 dahil may iwan sa denominator natin ay 2. Okay lang. And then, simplifying the equation, we get the shear max is equal to theta gd over 2L. So, given si shear max, given si theta, given si g, given si length, okay na. Ma-solve na natin si diameter natin. Okay? So, ito na yung equation natin for diameter. 2L shear max over theta g. Now, let us find for the diameter. So, computing for the diameter, substitution na lang gagawin natin. So, we have 2 times yung length natin na 5 meters. And again, naka-meter siya, gawin natin siyang millimeters. Tapos, shear max na 80 megapascal. Okay lang. Tapos, theta natin na 4 degrees. Tapos, dapat yung angle of twist natin naka-radians. So, conversion factor na pi over 180 to cancel yung degrees. Okay? And then, we have yung modulus of rigidity na 83 gigapascal. Tapos, multiply natin ng 1,000 para maging megapascal. So, like terms sila nang nasa taas. Okay? So, solving sa calculators natin, we will get the value for the diameter na 138.0621 millimeters. And again, store nyo siya sa calculators nyo for future use. So, that is yung first part ng problem 307 natin, finding the diameter. So, second part ng problem 307, tinatanong sa atin kung how much power ang pwede nating matransmit sa shaft na yon pagka pinaikot natin siya ng 20 Hz. Okay? So, 20 Hz tayo ang rotation natin. So, yung frequency natin ay 20 Hz. So, again, yung, di ba yung frequency, yung F natin kanina, sinabi doon number of revolutions per minute, revolutions per second. So, yung Hertz kasi, yung Hertz na unit natin, it is a cycles per second, kaya hindi na natin siya kailangan i-convert. Okay? So, ito yung given sa atin kanina, 5 meters, 80 megapascal, and so on and so forth. May nakuha na tayong diameter. Let us solve for power na. So for power, we have 2 pi torque times yung number of revolutions per second. Okay, so we have an equation for torque kanina in terms of diameter. So ito na lang isasalpak natin sa equation natin para hindi na tayo, para isang pindutan na lang sa calculators natin. Okay, so i-substitute natin yung t dito sa ating equation. So we have 2 pi theta g d raised to the 4 over 32L, tapos multiply natin yung number of revolutions per second. Okay? And then it's just a matter of substituting yung mga values na given. So we have 2 pi, angle of twist natin na 4 degrees. Tapos, dahil nga degrees, kailangan i-convert natin into radians. So, meron tayong conversion factor dito na pi over 180. Times yung 83 gigapascal na ating modulus of rigidity. And again, dahil gigapascal, kailangan natin siyang i-convert into megapascal. So we have a conversion factor na 1,000. Multiply natin yung 1,000 para maging megapascal. And then 138.0621, that is yung diameter ng ating shaft na nasolve natin kanina. All over, 32 times yung length natin na 5 meters. Tapos dapat naka-millimeters din siya, kaya multiply natin ng 1,000 para maging millimeters in meters. And then we have 20 hertz. So, yung 20 hertz, hindi na natin siya kailangang i-convert because it is a unit for cycles per second. So, pag isang cycle, parang isang rotation ang tinutukoy nyo dyan. Isang rotation per second. So, 20 hertz is just a unit of revolutions per second. Okay? So, therefore, yung magiging sagot natin, pag pinindot na sa calculators natin dyan, ay 5,194,611,889 Newton millimeter per second. So, hindi pa ito yung magiging sagot natin because yung units natin ay Newton millimeter per second. So, para mag-come up tayo with the correct, almost correct na to almost correct answer na to So, hanapin na lang natin yung unit na kailangan natin. So, sa power, ang unit natin for power ay watts. Right? Tapos yung watts natin, it is just equal to 1 joule per second. At yung 1 joule natin ay 1 Newton meter. So, kailangan nating gawing meter si millimeters dito para maging Newton meter per second tayo or joules per second. Okay? So, kaya naglagay tayo ng conversion factor dito na 1 meter all over 1,000 millimeter para mag-cancel out si millimeter. So, makukuha natin yung sagot na 5,194,611.889 watts. And that is just equal to 5.1946 megawatts. So, this will now be our answer for part 2 ng problem 307. Okay. So far, may mga tanong ba? Clarifications? So that is yung sample problem 307 natin. Next problem tayo. So this will be yung last problem, sample problem natin under torsion. Okay. So for this problem, a shaft with a constant diameter of 2 inches is loaded as shown in the figure below. So, by torques applied to gears fastened to it, so meron tayong mga gears attached to point A, point B, point C to point D. So, may mga gears tayo dyan, tapos meron applied moment or torque sa shaft A, ay sa gear A na 500 pound-foot, sa gear B, 900 pound-foot, that is counterclockwise, sa gear C na clockwise rotation na 1,000 pound-foot. Tapos sa gear D naman, meron tayong torque na 600 pound-foot. Okay? So if the modulus of rigidity ay 12 times 10 raised to 6 psi, compute in degrees the relative angle of twist between the gears. So relative angle of twist. So ilang degrees ba yung rotation ni D with respect to A. And to visualize that, so let us imagine from A to B, yung torque natin sa A ay 500 pounds, yung torque natin sa B ay 900 pounds. So, overall, meron tayong 500 clockwise tapos counterclockwise na 900. So, magkokontra sila. So, they will cancel each other out. So, maiiwan ay 400 pound-foot na counterclockwise dito. So, magti-twist siya ng counterclockwise pagdating sa B. Tapos, clockwise pagdating sa C. Tapos, counterclockwise ulit sa D. So, pag tinutukoy natin na relative angle of twist ng D with respect to A, ang kailangan lang natin kunin dito ay yung total angle of twist sa buong shaft. Okay? So again, pag sinasabi natin ay yung angle of twist of D with respect to A, ang kukunin lang natin ay yung total angle of twist sa buong system natin. Okay? From A to B to B to C to C to D. Taking into account yung sign natin. So, yung sign convention natin dito, pag clockwise, that is positive. Pag counterclockwise, that is negative. So, let us analyze it further. So, before pala yun, isolve na muna natin yung polar moment of inertia ng shaft natin. So, we have a shaft here that is 2 inches in diameter. So, meron tayong diameter na 2 inches. Solve natin yung polar moment of inertia ng solid steel shaft. So, we have J is equal to pi d raised to 4 over 32. So, yung diameter natin na 2 raised to 4 over 32. Yung moment of inertia, polar moment of inertia natin ay 0.5 pi inches raised to the 4th power. So, this is now yung polar moment of inertia natin. Okay lang? So, proceed tayo sa analysis natin dito sa ating figure bago natin ma-compute yung relative angle of twist. Okay? So, nakuha na natin yung polar moment of inertia, 0.5 pi inches to the 4th. Tapos, meron tayong given na modulus of rigidity. Let us draw first a torque diagram. So, dito sa torque diagram, parang dito natin makikita yung total torque na nag-o-occur sa isang shaft. So, para makapag-draw tayo ng torque diagram, let us consider a horizontal line. Tapos, diyan it signifies a zero torque line. Ibig sabihin, wala tayong torque. Pag yung graph natin or yung illustration natin, it reaches this line, ibig sabihin, zero na yung torque natin doon. Okay? So, after that, i-mimic lang natin yung distances ng A, B, C, D dito sa ating torque diagram. So, 4 feet, 3 feet, tsaka 5 feet. Tapos, andito si gear A, andito si gear B, gear C, tsaka gear D. So, point A, B, C, D. Okay? So, again, yung sign convention natin, pag clockwise, positive. Pag counterclockwise, negative. So, dito, from point A, from 0 torque, meron tayo sa point A natin, meron tayong clockwise na torque. So, ibig sabihin, itataas natin siya sa positive side ng 500 pound-foot. Okay lang? So, from 0, dahil sa point A natin, meron tayong 500 pound-foot na clockwise torque, itataas natin siya sa positive side ng 500 pound-foot. Okay? And then, from A to B, idiretso lang natin kasi wala namang naidagdag na torque. And then, dun sa B, nagkaroon tayo ng counterclockwise na torque. That is 900 pound-foot. So, from B, meron tayong 500 pound-foot. I-apply natin yung negative 900 pound-foot na torque. So, bababa tayo ng 900 units kasi negative. Kasi counterclockwise, kasi negative. So, the same lang siya. So, bababa tayo ng negative 900. So, we have 500 minus 900. That will give us negative 400 pound-foot na torque dito. Okay? From B to C naman, diretso lang tayo kasi wala naman na idagdag na torque. At pagdating natin dito sa C, meron na ulit tayong clockwise na torque that is 1,000 pound-foot. Okay? So, from negative, dito sa C natin, from negative 400 pound-foot, itataas natin siya ng 1,000 pound-foot kasi clockwise siya, so positive. Okay? So, negative 400 plus 1,000, that is equal to 600 pound-foot. And from C to D, walang naidagdag na torque, so idediretso lang natin. And then dito sa D, meron tayong counterclockwise na 600 pound-foot. Counterclockwise is negative, so from 600 pound-foot, negative 600 pound-foot, babalik tayo sa 0. Okay? So, in making this diagram, dapat babalik at babalik tayo sa 0 torque. Dahil kung hindi, walang equilibrium sa ating system. So, dapat merong equilibrium lagi sa ating system. So, what does this mean, itong torque diagram? Itong torque diagram, it shows yung mga torque sa mga shaft natin. For example, at shaft AB, ito yung torque na nag-o-occur dyan sa shaft na yan. So, pag isi-solve mo yung shearing stress, anything na kailangan ng torque, ito yung torque, yung value ng torque na kukunin natin, 500 pound-foot. Sa BC, ganun naman. So, pag kukunin natin yung angle of twist sa BC or yung shear stress sa BC, yung torque na gagamitin natin ay yung torque na nakikita natin dito sa ating torque diagram, which is negative 400 pound-foot. And ganoon din sa CD na 600 pound-foot. Okay? So, I hope nasundan yun. So, makikita natin yung application yan later sa mga susunod na ating steps. Okay? So, meron na tayong given na torques. Di ba yung equation natin for angle of twist, theta is equal to TL over JG. JG, meron tayong length, meron tayong torque. So, let us solve for deformation for shaft AB. Okay? So, gagawin natin, kunin natin yung deformation sa shaft AB, deformation sa shaft BC, deformation sa shaft CD, tapos kukunin natin yung total niya. Taking into account yung sign natin for clockwise and counterclockwise. Okay? So, for deformation for shaft AB, that is equal to theta AB, that is equal to TL over JG. And please keep in mind na yung TL, JG na ito ay yung sa AB lahat yung gagamitin natin. Okay? Yung torque natin sa AB, that is 500 pound-foot. Okay? So, pounds. So, yung unit natin dito sa ating modulus of rigidity ay PSI. So, dapat yung units natin naka-pounds tsaka naka-inch. So, 500 pound-foot. So, kailangan kong gawing inches si foot. Multiply ko ng 12. Okay? So, we have 500 times 12 pound inches na to. Times yung length natin na ng shaft AB na 5 feet. Tapos, dahil naka-feet, convert ko into inches. Kaya i-multiply ko ng 12. All over J, yung polar moment of inertia natin na 0.5 by inches to the 4, 12 times 10 raised to 6 PSI. Okay? Solving sa calculators natin, makukuha natin yung value na 0.019 radians. Okay? And again, store nyo siya sa A para hindi kayo mamali dun sa angle of twist na naka-degrees. Okay? So, dahil naka-radians, i-multiply natin sa conversion factor na 180 over pi. Makukuha natin yung sagot natin or yung angle of twist na naka-degrees na 1.0943 degrees. And again, i-store natin yan dito sa B. Okay. So, nasolve na natin yung angle of twist sa AB. Sa BC na lang tsaka sa CD. Okay. So, proceeding sa solution natin. So, solving for the deformation for shaft BC. So, we have theta BC is equal to TL over JG. Lahat ng variables na gagamitin natin dito ay yung para sa BC naman. Okay? So, yung torque natin sa BC ay negative 400 pound-foot. Please take into account yung yung mga signs niya. It signifies kung counterclockwise or clockwise yung mga rotation natin. Okay? So, kaya yung torque natin negative 400 pound-foot. Okay? And again, yung foot dapat maging inches for consistency sa units. So, multiply ko ng 12 para maging inches. And then yung length ng BC natin na 3 feet. Tapos, multiply ko ng 12 para maging inches. Okay. And same J, same G. Makukuha natin yung sagot natin na angle of twist na negative 9.1673 times 10 raised to negative 3 radians. Sorry, hindi siya inayos na naman ni PowerPoint yung yung presentation. So, 10 raised to negative 3 dapat ito. Radians. Okay? At para maging degrees siya, multiply natin sa conversion factor na 180 over pi. And we will get yung value ng ating angle of twist na negative 0.5252 degrees. And again, i-store natin siya sa D. Okay? And malapit na tayo, konti na lang. So, deformation for shaft CD. So, solve natin yung deformation for shaft CD. Ganun na ulit yung process niya. Ano? So, TL over JG. Yung gagamitin na torque tsaka length ay yung sa CD naman. So, we have yung torque sa CD ay positive. 600 pound-foot. So, naka-pound-foot siya. So, dapat maging inches itong unit niya. So, multiply ko ng 12. Tapos, yung length niya na 4 feet. Tapos, i-convert ko ulit into inches. Kaya, multiply ko siya ng 12. All over, same J, same G. Makukuha natin yung sagot natin na 0.01833 radians. Again, i-store nyo siya lagi. Okay? Sa in na siya. Okay? At dahil naka-radians to, let us solve for the angle of twist na naka-degrees. So, multiply lang natin ng conversion factor na 180 over pi. And then we will get the value 1.0505 degrees. And that is i-store natin sa F. Okay? So, nakuha na natin yung deformation sa shaft AB, BC, tsaka CD. Let us now solve for the total angle of twist. So, solving for the total angle of twist, so we have total angle of twist is equal to theta AB, theta BC, plus theta CD. Okay? So, ayan na. Pwede na nating isolve. So, dito natin makikita yung, yung kagandahan ng pag-i-store. Imbes na i-input nyo yung mga exact values na 0.01833. So, ang ilalagay mo na lang ay B plus D plus F. Okay? Para makuha mo yung total angle of twist. So, solving for the total angle of twist, 1.0943 degrees plus negative 0.5252 degrees plus 1.0505 degrees. Makukuha natin yung sagot na, inayos ulit ni PowerPoint yung mga scripts niya. So we have the final answer na 1.6195 degrees. And this will be yung final answer natin for this particular problem. Okay, so ito na yung angle of twist ng D with respect to A. So, any questions so far before we move on?